Okay, so in this question, we have addition of mixed numbers. So we could start off by doing the sum of our whole numbers, right? Where we add 1 and 2 and we get 3. Now, when we look at the fractions, remember that you have different denominators in this case, right? We identify the denominator here as 3 and the denominator in this fraction as 7. So if I want to find the sum of these two fractions, I have to remember that I cannot add fractions just like that. I have to pay attention to if the denominators are the same. And if the denominators are not the same, then I need to do a little process to get a denominator that both of these denominators can also go into. So I'm going to find a common denominator for 3 and 7. And the only way to get that common denominator is by finding LCM, right? So that abbreviation LCM sounds familiar, where it stands for lowest common multiple, right? Lowest common multiple. I want you to get the lowest common multiple of 3 and 7. You think you can do that? You remember how to find the lowest common multiple?
Yeah.
Alright, so if I ask you to find the LCM of 3 and 7, can you tell me what you're going to do or how you're going to go about it, or at least tell me what you think the LCM is? So remember, when we look for a multiple, we're looking for a number that both 3 and 7 can go into, right? They both must be able to divide that number without leaving a remainder. So easy way to do this, go to your timetables. I want you to look in your 3 times tables. And then when you finish looking at 3 times tables, I want you to look in your 7 times tables. And I want you to tell me what number appears in your 3 times tables and your 7 times tables, right? It has to appear in both of them. So can you tell me a number that you see in your 3 times tables that is also in your 7 times tables? Find any number?
3.
So it has to go into, remember, it has to be a number, sorry, that both 3 and 7 could go into. So go through the list with me. Here what I want you to actually do. Go to your 7 times tables. Tell me what numbers you see in your 7 times tables.
1.
Okay, what else? Now remember, the multiples is what we have to look at, right? The ones that you're getting when you multiply 1 by 7 and 2 by 7, etc. So tell me the list of numbers that you normally would call out for your 7 times tables. We do them earlier. I don't know if you remember. 7. What else?
14.
Good. What else?
21.
Right. Okay. We could keep going on, but I want you to go back to your 3 times
28.
tables. So now I want you to go back to your 3 times tables, right? Because we could have 7,
Yeah.
14, 21, 28. I want you to see if you find any of those numbers that you just called from in your 3 times tables. So for example,
21.
right, there you go. So when you look through your list, you realize that 21 is in your 3 times tables and it is also in your 7 times tables. That is what we call a common multiple, right? Now, because there is nothing lower than 21 that is in both the 3 and 7 times tables, 21 is our LCM, right? So this is how your LCM works. And that's an easy little way, if you remember your times tables, you could always just pull up that list and you could just check to see what is in both of them and use that as your LCM. Alright, so now that we get the LCM to be 21, right, we're going to tell ourselves that we need to bring them to, I don't know if you remember the game we played this morning. You remember the one where we were flipping over the cards and we were looking for the shapes?
Yeah.
Right, what type of fractions we were looking for again? It starts with an E. You remember that big word?
5, 6.
What was the big word for the fractions? E, Q, U, I, V, equivalent. You remember? Right, equivalent. So, although you give a little trouble, just pronounce it equivalent, right? Equivalent. So if you have fractions where the denominators are different, you bring them to a common denominator, where we are going to bring these fractions to equivalent fractions out of this new denominator. So in this case, we're going to express 1/3 as an equivalent fraction out of 21, and then we're going to express 4/7 as an equivalent fraction out of 21. And how we're going to do it is like this. How many times can 3 go into 21? So you remember where you found it in your 3 times tables? So you go back and you find 21, right? What number did we multiply 3 by to get 21?
7.
So 3 into 21 is 7, and I want you to multiply 1 by 7 for me. What is 1 by 7?
8.
1 multiplied by 7. We do it before the game as well, when we were playing the grabbing the tables.
7.
7. So 1 by 7 is 7, right? So I'll write it on this line. 1 by 7 is 7. Plus, how many times 7 could go into 21? So go to your timetables again. Go to 7. Right. So 7 into 21 is 3. And I want you to multiply 4 by 3 for me. What is 4 by 3?
12.
12. Alright. So we're going to write 12 on the line now. We're almost done. What is 7 plus 12? So if you add 7 and 12, how much you'll get?
19.
19. Very good. 19. Now this 19 is the numerator part of the fraction, and the denominator would be 21. Right? So before I continue, 19 over 21. Do 19 and 21 have any number that could go into both of them? Can you tell me a number that could go into 19 and 21 without leaving a remainder?
Nope.
No, there isn't any, because 19 is a prime number, which means it's only divisible by 1 and 19. And 21 has a few multiples, a few factors, but that's what it is, right? There's none that is common to 19 and 21 that we could reduce this. So anytime we're doing mixed numbers, you could also check to see if the result that you get for your equivalent fraction, if it could be reduced. And if it can be reduced, reduce it. If it cannot be reduced, which is the case for this, all we're going to do now is take our whole number. So remember, when we added the whole numbers, we said 1 plus 2 is 3, right? So we take the whole number, we write that as part of the answer, and now we're going to take the fraction and put it after the whole number, and we will get our answer, right? So when we write it, we'll have 3 and 19 over 21. And that's our answer for this question. Sounds like something that you could do again if you had to do a question like this?
Yeah.
Yeah?